Try the problems for yourself, then pause it, or I don't mean that. I mean try the problem for yourself, then push play. Compare your work to my work, see if your answers match up and you're in good shape. Then push pause, go on to the next problem, try it for yourself first, go as far as you can until you get stuck, then push play, get yourself unstuck, or compare your answers to the answers we've got, and make sure you star the ones that you don't know how to do, that you're fuzzy on, because those are the ones you're going to want to have good notes, good examples to look at so you can use on the test. So this first page, list all the features you can think of from these three families of functions. So a linear family, let's look at just graphs. Okay, the graph of a linear function is straight. It's easy to recognize. Has some kind of slope, but it's just straight forever on both ends. Quadratic, it is curvy, and it looks like a U. It's a parabola. So there's one point in the dead center called the vertex, and that is where it turns around and starts going the other way. So they're totally symmetric. You can fold it in half over this vertex. Exponential functions. Exponential functions start off small and grow at a really fast rate. So they curve and they go up really quick. Or if they shrink, they start off really big and then they shrink. So they look like one of these two curves. So the pictures, there's the differences in the three pictures. Okay, the functions, the equations, the linear equation is y equals mx plus b. Or we got the linear equation is just 4 equals 2 times x. A quadratic equation could be 4 equals 2 x squared. So quadratic, the biggest exponent is a 2. And an exponential equation could be like 4 equals 2 to the x. So when the variable is in the exponent spot, that's called an exponential equation. So linear and quadratic have a lot in common. They both grow by addition, or they shrink by subtraction. That's the same for quadratic. The exponential, though, that grows by multiplication, and it shrinks by division. So exponential, you want to have your money in a bank account that is following some kind of exponential formula because it grows the fastest. Those numbers get big real quick. Okay, on the next page we'll look at the tables, the differences in the tables, but here's what you got to understand. Exponential functions, and we did early on, we did a bunch of these in IXL, your first lesson, the Algebra 1 X2. So your exponential function, let's look at just probably the easiest one to understand. So if you have the function y equals 2 to the x, what that means is every day you're going to double what you had from the day before. So this is exponential growth. And I'm growing it at the rate of multiplying by 2. So for example, if you have day 1, if you put day 1 in here, 2 to the 1 is just 2. If you plug 2 in for x, 2 squared is 4. If you plug 3 in, 2 cubed is 2 times 2 times 2. That's 8. So what's happening to these numbers is 2 to a 4 you times by 2. 4 to a 8 times by 2. And it's going to keep going as you go forward. 8 is going to turn into a 16. That's going to turn into a 32. and so on and so forth. We're timesing each output by 2. Okay, so as you go backwards, you're dividing. 16 cut it in half is 8, cut it in half is 4, cut it in half is 2. Go backwards, cut it in half. If you cut 2 in half, it's going to be 1. Cut that in half, that's going to be 1/2. Cut that in half, that's going to be 1/4. You can imagine you keep going backwards forever. So let's look at a picture. Alright, so if I'm going to try and graph this, so these are like my days on the x-axis, day 1, day 2, day 3, day 4. So day 1, and my y is going to be the amount I have of whatever it is I'm doubling. So on day 1, I've got 2 of those things. On day 2, I got 4 of those things. On day 3, I've got 8 of those things. On day 4, I've got 16. So they start to grow really fast. But let's go backwards. On day 0, if I cut 1 in half, if I cut 2 in half, that's going to be 1. If I cut that in half, it's going to be a half. If I cut that in half, it's going to be a quarter. If I cut that in half, it's going to be an eighth, and then a 16th, and then a 32nd. So as you go backwards, you're cutting them in half. And this graph, your exponential graphs, this will never ever dip below 0. So as we go to the right, it gets bigger, 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 and it's going up, 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 up. It's going to go all the way up to positive infinity. The further I go to the right, the higher this graph goes. But if you go back to the left, it is going to get closer and closer and closer and closer to nothing. But it will never drop down into the negatives. Because no matter how many times you cut something in half, if you have a quantity, if you've got a pizza and you start cutting it in half, you can cut it in half an infinite number of times and you will still have a small amount left. You can't take half of something a million times and have a negative amount left. So exponential functions are going to look like this, and this dotted line is what it is approaching, but it will never cross. So for example, let's say we're gonna go backwards. Let's say you start off with like $1,000 in your account. So you got $1,000 clear up here. And then on the first day you cut that in half to 500, then you cut that in half, then you cut that in half, then you cut that in half. So this is shrinking. And if you keep going on and dividing that $1,000 into half, your dots are going to get smaller and smaller and smaller and smaller. So you started at $1,000, but it's shrinking to 500 to 250, and it's going down, down, down. But you can cut it in half as much as you want, and it will never go below 0. You'll still have some pennies or even fractions of pennies in your account. If you cut it in half, it's never going to have a negative amount in your account. So there's 2 types. This one right here is when it shrinks. It's called exponential decay. And the other one we just did, where it starts and gets big, 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 that's exponential growth. So 2 types of exponentials: growing or shrinking, growth or decay. Okay, looking at tables. All you've got to do for the test, you don't need to write the function, but you do need to identify which of the 3 families does that belong to. So this one right here, this first one, if you look at it, so kind of a hint is, look where I'm ending up. I'm ending up and my numbers are getting pretty big, so this is kind of a hint that this might be exponential. So over here, I I go for a ways, I end up at 55. And then over here I end up at 23. So this one by far gets the biggest. So it's probably exponential. And let's start figuring out how much it changed. So from 3 to 6, that went up 3. From 6 to 12, that went up 6. 12 to 24, that went up 12. 24 to 48, that went up 24. 48 to 96, that went up 48. Get this middle one. 1 to 7, that went up 6. 7 to 13, that went up 6. 13 to 19, that went up 6. 19 to 25. Okay, this one right here is the easiest. This one is linear. Linear is when it goes up the same amount every single time. This one right here, 23 to 14, that's shrinking. That went down 9. 14 to 7, that went down 7. 7 to 2, that went down 5. 2 to negative 1, that went down 3. And you can keep going. Okay, now, that's the easiest one to find, is when it's linear. Okay, these other two, we got to figure out which one is quadratic and which one's exponential. And this one right here is going to be the exponential. If you start picking it apart again, that's going to be up 3, up 6, up 12, up 24, and you can keep going. Up 3, up 6. It's going to never end. That's a hint that it's exponential, but look at this. You're timesing by 2. So 3 times 2 is 6, times 2 is 12, times 2 is 24, times 2 is 48. To get the next quantity, you're just doubling the one that you leave off on. And if it grows by multiplication, that is exponential. Okay, this one then's got to be the one from the quadratic. And the quadratic grows by addition, just like the linear. Or it shrinks by subtraction. So negative 9, negative 7, negative 5, negative 3. If you break it apart again, from negative 9 to negative 7, that's going up to negative 7 to negative 5. That's going up to negative 5 to negative 3. That's going up to. And if the second time you pick it apart, it's the same every time, that is, by definition, a quadratic. Okay, so there's those 3 types of families from tables. Now let's look at a picture. Let's try and match a graph. Okay, this right here, you look what's in the parentheses, and that will tell you if it's growing or decaying. So 1/3 is the same as divide by 3. If it's a fraction, that's kind of the same as division. So you're dividing something by 3, so that means it's going to look like this. It's going to start off big, and it's going to get small, small, small. So we're looking for something like this guy right here. So your model, we've got, if it's exponential, this right here, what's in the parentheses, that tells you if it's growing or shrinking. Okay, this guy right here is your vertical shift. That will move it up and down. So this is a -4. So we're looking at this one right here. B, we can cross off B. C, we can cross off C. D could be possible. Because this line right here at a -4, and this line right here at -4, that's what this -4 is. They shifted that graph down 4 units. So it's going to decay, so it's going to look like this, and then this out front, if there is a negative out front, the negative flips it over the x-axis. So this one, if you flip it over the x-axis, it's going to look something like this. So we're looking for one that looks like this, and that is D. Because if you flip A up, it's going to look like this. And we need it to look just like this guy right here. So we're going to go with D. Okay, the next one. If I give you 4 pictures, can you write your own equation that could describe the graph? So there's more than one right answer. There's thousands of right answers. This guy right here, the dotted line looks like it's been shifted up 1. So whatever we've got at the end, we're going to have a plus 1. And this one, it started big, and then as time goes on, it's getting smaller, 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 smaller. So this one has to be decay. And that means whatever you got in the parentheses, you're dividing. So it's going to be a fraction. If I put 1/5, that means I'm dividing by 5 every time. So I got x right there, and you could leave it right there. This graph and equation could match each other. They could describe each other. Okay, look at the next one. You're starting small, but as time goes on, it's getting bigger, 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 bigger. So this one is modeling something that's growing. So this is a model of exponential growth. Okay, the dotted line, it looks like it has been shifted down to a -4. So whatever I've got at the very end is going to be -4. And because it's growth, what's in the parentheses needs to be the whole number. So that 10 means every time I'm timesing it by 10. This is what I'm timesing by. So times by 10, times by 10, times by 10. Okay, these bottom two have been flipped. And when you put a negative out in the very front, that is what flips it. So here's what it used to be. If I flip this back up over this line, it's going to look like this, which should be decay. Because it starts big and gets small, 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 so it's going to be decay. So if we take this first one right here, y equals 1/5, or divide by 5 to the x. Okay, my line is -1. It has to be -1 because this line was shifted down once. Usually it is always left at 0. It's going to approach 0. It's going to get closer and closer to 0. Always getting closer and closer to 0. But if I shift it up and down, then it's not going to approach 0. This guy right here is getting closer and closer to a -1. So the 1/5 means I'm dividing by 5, so it's decay, but then I need to flip it, so I got to put a negative here. So the 3 things that make this right: A, if you have a negative; B, if this is some kind of a fraction; and C, if that is a -1. Okay, my last one has been flipped, so I'm going to flip it right side up. Okay, this one is a model of growth, just like the one above it. So I can use that same formula, except for I'm going to have to change this part. So if I go y equals 10 to the x, I'm going to keep it at -4 because this line is still at -4. So the 10 means every time I'm timesing by 10, and now I've just got to flip it, so I put a negative out here. Okay, then we got into some equations with square roots. And you got to remember, how you undo a square root is by squaring something. So move number 1. We have to solve for x. We got to get rid of that 2, we got to get rid of that 15, and we got to get rid of this square root, and we got to get rid of this +5. So first, you have to undo anything that's outside of the square root. So I got to undo this +5 first. So I'm going to -5, -5. So here's what I got. I got square root of 2x plus 15 equals 18 minus 5, so that's going to be 13. Now, I've got to get to the x, but the x is hanging out with 2 and 15 in the square root. They're both under the square root, so I got to lift it off. I got to undo the square root, so I'm going to square this side, and then I got to square this side. So on the right side, I'm going to have 169. On the left, this square cancels that square root, so I just got 2x plus 15. And now undo everything with the x. Undo this plus 15 first. So minus 15, minus 15, and 169 minus 15. It's going to be 154. So I got 2x is 154. Undo the times 2, divide 2, divide 2. And if you cut 154 in half, x should end up being 77. The next one, first of all, we've got two things on the outside. We've got subtract 3 and we've got 6 times. So undo the plus or minus first. So I'm going to plus 3 plus 3. So you got 6 times the square root of 3x over 3 equals 3. Okay, now I got to undo the times 6. And how you undo times is divide. So divide by 6, divide by 6. 6 divided by 6 is 1. So we got the square root of 3x over 3 equals 3/6 is 1/2. Now I've got to get rid of this. I got to lift off this square root. So I'm going to square this and I'm going to square this. So this square undoes the square root. And if you have 1/2 squared, that's 1/2 times itself, 1/2. Which is times your tops, that's 1, times your bottoms, 2 times 2 is 4. So here's what I got. I got 3x over 3 equals 1/4. But this 3 over 3, you can simplify that. 3 divided by 3 is just 1. So you got just x is 1/4, and that is your answer. Okay, this last one is kind of tricky. So I gotta get t all by itself. I've gotta undo everything with t. There's nothing outside of the square root, so I'm gonna lift it off. I'm gonna square this, I'm gonna square this. This square undoes that square root, but you need to square both of them. 8 square roots of 6 squared is 8 squared to 6 times 8 squared to 6. Or you distribute that 2 to both of them, to the 8 and to the square root of 6. So 8 times 8, that's going to be 64. And square root of 6 times square root of 6 is going to be square root of 36. And that's a perfect square. Square root of 36 is 6. So you really just have 64 times 6. So here's what we've got. On the left, we've got 6t plus 12. On the right, we got 64 times 6, which is 384. Now you undo the plus 12, so this minus 12, minus 12. 384 minus 12 is 372. On the left, we got 6t. Undo the times 6, so divide 6, divide 6. So 372 divided 6, x is 62. Okay, so your equations, but now x is in the exponent spot. So before, x was underneath the radicals, and you got to know how to undo a radical. This one, if x is in the exponent spot, here's what we're going to try and do. We're going to try and make these two bases be the same. Because if the bases are the same, then the exponents have to be the same. So move number 1. This 1 over 81, that's division. You're dividing by 81 and you're dividing by 27. So I'm going to rewrite this fraction. I'm going to write it as 81 to the negative 1. And over here, I'm going to put the 4x minus 1. Then on the right hand side, 1 over 27, that's 27 to the negative 1. Then we got 5x. Okay, now look at your bases. They're a lot easier to look at as whole numbers instead of fractions. 81 and 27. So you look at the small one, and I'm going to try and turn 27 in. No, I went backwards. You look at the big one, and you're going to see if you can turn it into the small one. So 27, on my calculator, I'm going to do 27 times 27. 27 times 27 is equal to 729. So I cannot turn a 27 into an 81. So I've got to change both these bases, and I've got to change them to something that is smaller than 27. And I know 27, you can use a bunch of 3's to make 27. So you can do 3 times 3, which is 9, times 3, which is 27. So you can swap out 27 for 3 cubed. And if you take that 27 and you times it one more time by 3, that's your 81. So you can create an 81 just with 3's, and you can create a 27 just with 3's. So 27 is 3 3's, and 81 is 4 3's. So now I'm going to swap out 81 for 3 to the 4th. But it's got to be a negative 4, because this is a negative 1. Okay, and on the right side, the 27, I'm going to swap out a 27 for 3 to the negative 3. Okay, now here's what we've got. We're in business. My bases are now the same. So if your bases are the same, these exponents have to be the same. But first, I've got to clean up these exponents. I've got to times these by a negative 4. So a negative 4 times 4 is a negative 16x, and a negative 4 times a negative 1 is a positive 4. And then on the right hand side, a negative 3 times 5x is a negative 15x. And now I can just totally ignore the bases, because the bases are both 3, so I just look at the exponents. Don't worry about the bases. Okay, now we just do cops and robbers, solve it. So I'm going to move these x's over here. So I'm going to plus 15 x's, and I'm going to plus 15 x's. So I've got a negative 1x plus 4 is greater than or equal to 0. So I'm going to minus 4, minus 4. So I got a negative x is greater than or equal to a negative 4. Now I'm going to undo the negative. I'm going to divide by a negative 1, divide this by a negative 1. So x, negative 4 divided by negative 1 is positive 4. But because you divided both sides of an inequality by a negative, you need to change the direction of your inequality. So your final answer should be x is less than or equal to 4, or it could even be this way. X is less than or equal to 4. It's got to be pointing to the x. Pointing to the x. Doesn't matter if you write it either way, but it has to be pointing to the x. Okay, the next one. So move number 1. This is division, which is a negative exponent. So I'm going to go 36 to the negative 1 to the n. Then on the right hand side, I got 216 to the n plus 5. Okay, now, can I create a 216 just with 36's? So 36 times 36 is the question. 36 times 36 is 1296, so that's not it. So that's going to be like this first one. I have to use something smaller than 36. And 36, I know we can do 6 times 6 is 36. So I can create a 36 by using 6's. And that is 6 squared. So 216, if I do 6 times 6 times 6, if I do 3 6's, that is 216. So here we go. These are going to be my two new bases, 6 squared and 6 cubed. So this first one, 36 to the negative 1, I'm going to change 36 for 6 squared, but it's going to be a negative 2. And I'm going to trade 216 for 6 cubed. Okay. Now, if I do a negative 2 times n, that's going to be a negative 2n. And then on this side, I got to times everything by 3. So 3 times n is going to be 3n. 3 times 5 is going to be 15. Now I'm going to move my n's to the left, so I'm going to go minus 3n, minus 3n. That's gone, and then I've got a minus 2n and a minus 3n, so it's minus 5n. Then on the right, I've got 15. So divide by a minus 5, divide by a minus 5, and 15 divided by a minus 5. We've got n is equal to a negative 3. Okay, now we're going to simplify radicals. So this first one, everything outside plays together. So 5 and 15, you need to change that to 1 over 3. Divide them both by 5. Okay, now you got square root of 4x cubed. And then on the bottom, you got square root of 12x to the 6. Okay, the ones that are underneath play together. So 4 and 12 play together. You need to change that. 4 and 12, divide them both by 4, so that's going to be again a 1 and a 3. And then your x's, if you've got x cubed on top, that means you've got 3 x's on top. And on bottom, if you got x to the 6th, that's going to be 6 x's on bottom. X divide x, that one undoes, that one undoes, that one undoes. So 3 of these x's on top are going to undo 3 of the x's on bottom. So my leftovers are on bottom, and there's going to be 3 of them. Okay, so now on top, all you really have is a 1, and on bottom you got 3 times the square root of 3x cubed. I'm going to break it up. That's x. There is a square in x cubed, so I'm going to take that square out. So a pair of x's is coming out with the 3. So now on top you got a 1, on bottom you got 3x on the outside, and on the inside you're going to have 3 and x. Now we're getting close. It is unacceptable to have a radical on the bottom, so you got to get rid of this square root of 3x. And it's pretty easy fix. All you're going to do is times the bottom by square root of 3x, times the top by square root of 3x. Because square root of 3x divided by square root of 3x, that's just 1. And you can times anything by 1 and you don't really change its value. So on top, 1 times square root of 3x is going to be square root of 3x. On the bottom, 3x is on the outside, and on the outside of this is just an invisible 1, so times your outsides together. So that's going to be 3x, and now times your insides together, which is going to be square root times these guys together. That's 9x squared, and you just created a perfect square. Because square root of 9x squared, or square root of 9, is going to be 3, and x squared, there's going to be an x that comes on the outside. And on the outside you already have 3x, so you times those together. 3 times 3 is 9. X times x is x squared. You add the exponents. When you times letters, add the exponents, so it's 9x squared. So on the top we got square root of 3x, on the bottom we got 9x squared. That one was pretty tough. Okay, the next one, let's see if there are any squares that can be pulled out. In 27 is 9 times 3. 3 is done, and 9 is my perfect square. 9 is 3 times 3. So I'm going to take this pair of 3's out, and there's already a negative 2 on the outside, so it's going to be a negative 2 times 3. So on the outside I got negative 6. On the inside I've got this 3. Okay, the next one. In 40, 4 and 10. 4 is my perfect square. 4 is 2 and 2. 10 is 2 and 5. Okay, there's my pair of 2's. So 2 goes out, and there's already a 3 out, so times 2 and 3, and you get 6. And what's left on the inside is this 2, and 5 times them, 10 on the inside. Okay, last one, 108. 108 is going to be 2 and 54. 2 is done. 54 is 9 and 6. 9, there's my perfect square. 9 is a 3 and a 3. 6 is 2 and 3. So check this out. In 108, I have 3, 3, 3, 2, 2. So I got a pair of 3's and I got a pair of 2's. So take the 3 out, take the 2 out. 3 times 2 on the outside you should have 6, and on the inside you have 3. Okay, now these 3 terms, this and this will play together because they're both square roots of 3. So if I've got a minus 6 square roots of 3 and a plus 6 square roots of 3, they're opposites, so there's 0. You add them up and you got nothing. So your answer is going to be 6 square roots of 10. Okay, last page. Looks ugly. This looks pretty tough. So let's start by seeing what is inside of 6,300. 6,300. Times it by, divide it by 100. So 163. Okay, 100, that's a perfect square. That is 10 times 10. So there's a pair of 10s that come out. 63 is 9 times 7. And 9, there's my perfect square. That's going to be 3 times 3. There's a pair of 3's. And then what's left is this 7. So 10 is coming out and 3 is coming out. So on the outside you've got 4. Times it by the 10, times it by the 3. And the number that's left inside is the 7. Okay, now let's start taking out some letters. If you've got x to the 27, you have 27 x's. There's plenty of pairs in there. So what we're going to pull out is 27. I'm going to go one smaller. 26 times x to the 1. So that's 27 x's. So if it's an odd amount, I just go down 1. So subtract 1 from 27, that's 26, and then 1 left over, so there's my 27. If I have 26 x's, that means 13 of them are coming out. So 4 times 10 is 40 times 3. On the outside I got 120, and I'm taking out 13 x's. But I'm leaving in a 7, and I'm leaving in this leftover x. Okay, 65 y's. So that's like 64 y's. So I'm just going subtracting 1 to find an even number. 64 of them, that means how many pairs, how many 2's are in 64. So that means 32 are coming out. And this 1 stays left over. Okay, the z's, 6,300. That's an even amount, so all of the z's come out. So how many pairs are there? If you got 6,300, my z's, I'm going to have 3,150. So no z's. The only thing that's left in is 7, x, and y. So my answer should be 120, x to the 13, y to the 32, z to the 350, or no, z to the 3,150. Okay, so that's not too bad. Alright, next. If we're going to square it, we need to times it by itself. So the 3x times square root of 8x cubed times that by itself. 3x times square root of 8x cubed. Okay, now the outside times the outside. 3x times 3x. 3 times 3 is 9. X times x is x 1 plus 1. So it's x squared. And then this this square is going to kill this square root. So I'm just going to have times 8x cubed. Because it's going to create, if you times your insides and insides, that's going to be square root of 8 times 8 is 64. And square root of 64 is 8. And then x3 times x3 is going to be x6. And the square root of x6 is x3. So now times the 9 and the 8, that's 72. And times your x2, x squared times x cubed, so it's going to be x to the 2 plus 3. So it's going to be x to the 5th. 72x to the 5th is your final answer. Okay, last one. No, we have done that one. I think we just did that one right here. We did it over here. So, the thing to remember is your outside numbers play together. Simplify it first. Change 5/15ths to a third. Clean up all your inside stuff. And that is it. That's the review. If you can do those, you'll do well on the test. So, start the ones that you don't know, that you're not very good at. Get some examples. Put them in your notes so you can use notes on the test. And make sure you come ready.